everyone, and welcome to today's Explainer. I am so incredibly excited to be your guide today. Let's be honest for a second. Math can sometimes feel, well, a little bit overwhelming, but I'm here to save you those hefty tuition fees and make this whole process as painless and actually as fascinating as possible. Today, we're taking coordinate geometry and breaking it down in completely simple terms. We're going to take what looks like complex math on a grid and turn it into something you just intuitively understand. But hey, before we even look at a single graph, let me ask you something. Have you ever wondered how food delivery apps like Swiggy, Zomato, or Uber Eats pinpoint your exact location without getting lost? Like, when you drop that little pin on a map to get your dinner, do you actually think the app's computer brain is reading your street name? Definitely not. Computers don't care about street names. They only know numbers. So how exactly does that delivery driver end up right at your doorstep every single time? Well, the answer is coordinates. Coordinates are basically just the mathematical address of a point on a flat surface. Think of it like a highly precise, hyper-specific zip code for just a tiny speck of space. Whether it's a dot on a piece of paper, a pixel lighting up on your phone screen, or your exact house on a digital map, coordinates give us this universal language to locate anything, anywhere, with absolutely zero confusion. So, to turn you into a coordinate master today, here is our game plan. We'll be walking through 5 key topics. First, the secret of location. Second, the Cartesian system and René Descartes. Third, quadrants and their rules. Fourth, hidden points on axes. And finally, the magic of mirror images. Let's dive right in. All right, kicking things off, section 1, the secret of location. So imagine you just drew a single dot on a completely blank piece of paper. To tell someone exactly where that dot is without literally pointing your finger at it, you need a reference system. And we build that system in 2 really simple steps. Step 1, you just draw a horizontal number line lying flat. We call this the x-axis. Step 2, you draw a vertical number line standing straight up, crossing right through that first one. And we call this the y-axis. Suddenly, that blank piece of paper, it isn't so blank anymore. By using these 2 crossing number lines, we've created a grid. It's a precise way to measure exactly how far left, right, up, or down our dot is. Moving right along to section 2, the Cartesian system and René Descartes. Now, you know this entire grid system didn't just appear out of thin air. It was actually invented by a brilliant mathematician. And the legend goes that René Descartes was just lying in bed one day, staring idly up at his ceiling. He noticed a small bug, maybe an ant or a fly, just crawling across the flat surface. And he started wondering, how could I mathematically describe the exact path and location of that bug at any given second? He realized that if he used 2 intersecting lines as reference walls, he could track the bug's exact distance from each wall, and boom, the Cartesian coordinate system was born. Literally going from a bug on a ceiling to the GPS in your phone. How cool is that? So, the absolutely crucial part here is how we actually use these numbers. Every address has 2 parts, an x-coordinate, which has this fancy mathematical name called the abscissa, and a y-coordinate known as the ordinate. But listen, I really need you to pay attention right here, because this is the single most counterintuitive, tricky rule in all of coordinate geometry. The x-coordinate is actually your perpendicular distance from the vertical y-axis. Let me say that one more time. Your x number is how far you walk away from the y wall. And conversely, the y-coordinate is your perpendicular distance from the flat x-axis. So if your coordinates are, say, 5, 4, you are 5 steps away from the y-axis and 4 steps away from the x-axis. If you can memorize this one counterintuitive flip, you will literally never get a coordinate question wrong. Okay, which brings us to section 3, quadrants and their rules. When Descartes crossed his horizontal x and vertical y lines, they naturally sliced our flat space into 4 distinct rooms, or quadrants. And here is your ultimate cheat sheet to navigate them. The best part? You don't even need to plot points on a graph to know which room they live in, you just have to look at their positive and negative signs. In the first quadrant, that's the upper right room. Both x and y are positive. Over in the second quadrant, the upper left, x is negative but y stays positive. Drop straight down into the third quadrant in the bottom left and, well, everything is negative. Minus x, minus y. Finally, swing over to the fourth quadrant on the bottom right, and x goes back to being positive, but y remains negative. Let's test this out. Take the point -4, 6. Without drawing anything at all, you can instantly tell me where it lives. The x is negative, the y is positive. A negative x and a positive y instantly tells us this point lives squarely in the second quadrant. Once you grasp this simple sign pattern, navigating the coordinate plane just becomes completely second nature. Onward to section 4, hidden points on axes. So all about the 4 rooms now. But what happens if a point isn't in a room at all, but is sitting directly on the wall itself? Think of it like this. If I ask you right now, hey, how far are you from your house? And you are literally sitting inside your house, your answer is 0, right? Well, the exact same logic applies here. If a point is sitting directly on the x-axis, its distance from the x-axis is 0. And remember our tricky rule from earlier? Distance from the x-axis is the y-coordinate. So any point on the x-axis always has a y-coordinate of 0. And conversely, if a point lives right on the y-axis, its distance from the y-axis is 0, making its x-coordinate always 0.
And that brings us to the grand champion, the absolute VIP of all coordinate points, 0, 0. This highly specific point has a very special name. It's called the origin. It is the exact dead center where the x and y axes cross. Now, why is it exactly 0, 0? Because it sits on both the x-axis and the y-axis simultaneously. Its distance from the vertical wall is absolute 0, and its distance from the flat floor is absolute 0. It is the starting line for literally everything in coordinate geometry.
And finally, section 5, the magic of mirror images. Imagine placing a mirror right on one of our axes to look at the reflection of the point. Now, here is an incredible shortcut for finding those reflections without having to draw out any complex diagrams. Are you ready? All you have to do is flip the sign of the axis that is not acting as the mirror. Okay, so if the problem says the x-axis is the mirror, your x value stays exactly the same, and you just flip the sign of your y-coordinate. But if the y-axis is the mirror, your y value stays exactly the same, and you just flip the sign of your x-coordinate. The mirror keeps its own letter safe, and the other letter takes the opposite sign. It's that simple. Let's look at a quick example. Take our point, -4, 5. Let's say we're told the y-axis is our mirror. According to our trick, the y-axis protects the y-coordinate. So the 5, it stays exactly as a positive 5, but the x-coordinate has to flip its sign. So, -4 magically becomes positive 4. Just like that, the mirror image jumps from the second quadrant straight into the first quadrant at positive 4, positive 5. It's just incredibly elegant, isn't it? But we have covered a ton of ground today, from Rene Descartes lying in bed, watching a bug, to the magic of mirror images. But before I let you go, I want to leave you with a little homework question to really test out your new coordinate superpowers. Here it is. If the number a is strictly greater than 0, and the number b is strictly less than 0, in which quadrant will the coordinate point a, b lie? Really think about what greater than 0 and less than 0 mean for your positive and negative signs, and just match it up to our quadrant rules. I'm going to let you ponder that one. Thank you so much for exploring the Cartesian plane with me today in this explainer. Stay curious.